This is the video solution to Newton's second law example problem. An 8,550 Newton car has an engine that propels it forward by a 1,750 Newton force. The car travels from 5 meters per second to 15 meters per second. How much time did this maneuver take? Ignore frictional forces opposing the car's motion. Let's start with what we know, and that's listed in our givens. In our givens, we'll start with the first number, 8,550 newtons. This number describes the car. So it's an adjective describing the car. In other words, it's the weight of the car in this case. So the 8,550 newtons, because it describes the car, is the weight, 8,550 newtons. The next force is the force that moves the car because it propels it. That's 1,750 newtons. The initial velocity is 5 meters per second, and it travels up to 15 meters per second. And the question is, how much time did all this take? So this is where I start with my givens. So it's a big problem. In order to solve it, I'm going to start with the end. How much time did this maneuver take? So I'm looking for time, and I got my two velocities. And if I think about it a little bit, I realize that I can use kinematics. So the first thing I'm thinking is I'll use kinematics to find the time. That's the final answer. But if I'm going to do that, I don't have acceleration. So I need to find the acceleration. To find the acceleration, if I look at my givens over here, I can think, well, maybe I could use the second law. So my second step here, finding the acceleration using the second law. Almost. I don't have the mass, so I need to find the mass. So let's say I can find the mass. Well, I can find the mass from the weight, W equals mg. So these are the steps in backwards order. I started with the end of the problem and worked my way up to the front. So how I'm going to approach this problem is reversing it. So 3 becomes 1, 1 becomes 3. So the first thing I'm going to do is I'm going to find the mass from the weight. So W is equal to mg. Isolate the mass. W over g is equal to 8,850 newtons divided by 9.8 meters per second squared. Find the mass, storing it in my calculator with all the decimal places. Next step in my process, I'm going to find the acceleration from the second law. So F equals ma, isolate a, F equals F over m, and that's 1,750 newtons divided by 872, et cetera, kilograms. Find the acceleration, 2.0058, 47953 meters per second squared. Again, storing in my calculator, keeping all my decimal places. Now it's time to find the time using kinematics. It's the last step. So I've got all my givens that I need now. I'll start with v equals v naught plus at. Isolate t and plug in my numbers with units. And I get the time to be 4.9854227 seconds. 3 sig figs, that comes out to be 4.99 seconds. So now let's talk about how this is organized. You can see it's kind of done in 3 sections. And in each section, it looks the same. That is, it all starts with the base equation that I'm using. Then I isolate my unknown, put in numbers and units in each section. And my final answer has all the decimal places with units on it. Now, how do you organize the paper? Well, you organize the paper as if it was a newspaper. That is, you start in the top left, you go down, over, and down. So top left, down, over, and then down. This makes it very readable for you and me to see what's going on.